Okay, a little sharing again. All right, you're going to love today, because if you thought yesterday was a lot of work, today is not. I can't find my pen. What the heck? Well, there it is. Okay. We're staying in this section. We're going to spend a couple more days here, actually. 3-4, day 2. And your goal today, that work you did yesterday, all those long problems, was way, way too much work. So your goal is to look for a shortcut here. Find a shortcut to derivatives. Okay, I want you to stop writing, and I'm going to write down the problems from yesterday, the problem and your answer. And in a minute, I think a lot of you are going to be able to see, boy, this was actually pretty easy if I had noticed it earlier. Your first problem, the original function was 7x to the 4th. Okay, you're not writing any of this now, you're just looking. Your derivative answer was 28 x cubed. Look for a connection between these two. If you don't see it yet, this was your second problem. G of x equals 5x cubed. Your derivative answer, if you did it correctly after a half a page of algebra, was 15 x squared. Look for a connection. About this point, there's usually half the class ready to jump out of their chair because they said, oh my God, it's that easy. If you still don't have it, your next problem was v of t equaled 10 t squared minus 5t plus 7 in your derivative answer. Think about what you think your shortcut is here. Came out 20t minus 5. And the last one, s of t, was t to the 4th minus 6t squared plus 3.7. Your derivative function was 4 t cubed minus 12t. All right, how many of you got the shortcut? Hopefully a lot. If not, here it is. Take a look. If you take the exponent and you bring it down as a multiplier, 4 times 7 is 28, and it looks like we subtracted 1 from here. Let's see if that works in the next one. The exponent comes down as a multiplier. 3 times 5 is 18. 1 less than 3 is 2. Here, 2 times the 10 gives me 20. 2 minus 1 brings me down to t to the 1st. This is a t to the 1st. There's a 1 there. We don't write it. 1 times 5 is 5. T to the 0, anything to the 0 power is 1, not 0. And then this constant went away. Here, there's a 1 out in front of this t here. So the 4 came down, got multiplied by the 1. 1 less than 4 is 3. 2 got multiplied by the 6 for 12. 1 less than 2 is 1. There's nothing here. It's a constant. Went to 0. Okay, so your shortcut. Now you can write the derivative shortcut is if f of x equals ax to the nth, a is your coefficient, n's the power, then the derivative, f prime of x, the n comes down as a multiplier, gets multiplied by the a, so a times n, x, and you decrease the exponent by 1. That's as hard as it is. And then the other thing to remember is that the derivative of a constant is 0. And the reason that is because a constant function is a horizontal line, and the slope on a horizontal line is 0. So if the function is a constant, then the derivative is always 0. All right. Some derivative terminology you're going to need to know. Derivative terminology and symbolism. Okay, I think there's only 2 phrases I can think of off the top of my head. Find the derivative and differentiate. Differentiate just means find the derivative. Oops. So find the derivative, differentiate, those are interchangeable terms. They both mean just find the derivative. And the symbolism. You've seen the primes from yesterday. F prime of x. Maybe it's just a y equal, so it would be y prime. Some new ones that you haven't seen. Dy over dx is just another way to say f prime of x, or y prime. That just means the derivative of y with respect to x. Another one looks like this. Dx of y. So it's the derivative with respect to x of function y. All 3 of these are the same. The y prime, the dy dx, and dx of y are all the same. And the other one is dx of some kind of a function in there. This is telling you to take the derivative of what's inside the parentheses. Now, on a quiz or a test, if you mess up the symbolism, you will lose points. So as we go through the examples, I'll be pointing out which ones are appropriate for the kind of problem that we have. So make sure you label things correctly. All right, so just examples, practicing this shortcut rule. We have 2 of them, one where there's an exponent, one where there's a constant function. So here we go. All of these, the directions are find the derivative function. First one, f of x equals 4x to the 6th plus 2x to the 4th plus 7x squared minus x minus 5. So because I've got an f here, my only option is to use f prime of x. Okay, the shortcut says take the exponent and multiply. 24, x decrease by 1. Go to the next term. That'll be 8, x, 1 less power, 8x cubed. Multiply, that's 14, x, that'll be to the first, so that's just x. The exponent here, remember, is a 1. It's getting multiplied by the negative 1 out in front, so I've got negative 1. That'll come down to x to the 0. X to the 0 is 1, so it just goes away. Constant goes to 0. So the derivative of negative 5 is 0. Okay, try another. That's as quick and easy today. So f of x equals 0.61 x to the negative 9th. Okay, nothing different here. Same rules apply. F prime of x, you have to tell me you're doing the derivative. You cannot say f of x equals after you've done the derivative because it's not. It's a new function. Multiply. Negative 9 times 0.61 is a negative 5.49. X, if I subtract 1, think about it. Negative 9 subtract 1, I'm going to be at negative 10. Okay, try another. I've got y equals x to the 12th over 5 plus 3x squared minus 1. Okay, because this is starting with a y, I can't go with f prime of x. I've got to use one of the other ones. And I've got options where I can either use y prime equals, I could say dy over dx equals, or I could say dx of y equals. So any one of these three I can use. I'm going to go with y prime on this one. I'm going to use them all through today's. Now, this term here, the 12 comes down as a multiplier, but what is the coefficient here? The coefficient is not 1, it's 1/5. You could rewrite this term as 1/5 x to the 12th. Instead of x to the 12th over 5, now you can easily see the coefficient is 1/5, and that's what the 12 is going to get multiplied by. So think of that as 12 over 1, multiply numerators, multiply denominators. That's going to give you 12/5. X to the 1 less power is going to bring me down to the 11th. And now I move on to the next term. 6 x to the 1st, constant goes to 0. You can leave it like this, or you can bring it back, and it's fine to do an equals here because this is still the derivative. You can bring it back into a single fraction by going 12 x to the 11th all over 5. I don't care which one you do, they're both correct. Okay. Alright. 4. Look at how quick they're going today. Y equals 6x to the 3/5. Fractional exponent. Just going to work with some fractions. Okay, so again, I've got a y starting. I'm doing derivatives, so I'm going to tell myself the next line is the derivative. I can go y prime. I'm going to choose to use one of the other ones, just seeing all of them. dy dx means derivative. The derivative of the y function with respect to x. So, that comes down 6 times 3/5. If you can do that in your head, that's fine. I'm going to write it out. 6 over 1 times the 3/5. X to the 1 less power. I've got to subtract 1 from that. 1 over 1. Remember, to subtract fractions, you need a common denominator. So since I've got a 5 here, I'll make this 5 over 5. So now my numerator is 3 minus 5 is a negative 2/5. And I should rewrite that as 18/5 x to the negative 2/5. Or if you want to combine it into 1, 18x to the negative 2/5 all over the denominator 5. Either of these two answers is fine. I have no preference. Okay, dx of